Hi everyone, we are going to look into 5D or in extension textbook 6D today. Is trig function of a general angle. So two key things here is general angle and trig function. So we're going to quickly go into, we just go straight into that. Okay, so first is array. Array is like array is basically a line, a line going from the center or the origin. That's array. And obviously, if you go from the center from the origin, you will have a angle. So this angle here, let's say theta. Okay. So let's say this angle, this array is making angle 60 degrees. Okay. So we got a array now 60 degrees, and general angle is for general angle. This is the equation. Okay. Okay, so general angle basically theta could plus and minus 360 degree and remain the same value. So in this case, if this 60 degree angle, if I turn 360 counterclockwise, so minus 360 degrees, so negative 300 degrees, is still the same position. And if you go clockwise 360 degrees, it will still be the same position. So even though it's 420 degrees, it will be exactly the same location. That's what general angle means. And the n is a integer. Okay, so for any n, this value is true, and plus or minus 360. No, the general angle is theta plus minus 360 n. In this case, is 60 plus and minus 360 n. Doesn't matter. So you can just keep going in each directions. It's exactly the same location. Okay. Now, this is another thing we're going to look at today is how we measure the angle. For trigonometry, every time we measure angles, we measure from the x-axis. So not just measure, is label. Okay, so from x-axis. Okay, so we talk about this angle when we do trigs, trigonometry. So yeah, we're gonna go a little bit deeper into that one. Okay, now just do a little bit more here. I got a ray. I got a circle of 5 unit radius, and let's start with this one. So we have a theta here. Yeah, I got an angle. We call that theta. For an angle, we got a dot here. The dot had coordinates, so you got an x value and a y value, isn't it? Okay. And the radius is the same across. There's r is 5 here. So as you can see, every single dot on the circle has x and y values, and also have a r and theta values. So we can basically represent the location of x and y using radius, how far it is from the center of the circle, and how big the angle make from x-axis. Okay, positive x-axis. Okay, so it just open up another way we deal with color geometry. We're going to do a little bit more of that later, especially later on with even 3 and 4 unit topics, even 2 unit as well. 2, 3, 4 unit will heavily rely on that later on. Okay. Well, since it's trigonometry, let's get started with what it can represent, the ratio that it represents. So let's do sine first. I like sine a lot. So if sine theta with opposite over hypotenuse here, it will be y over hypotenuse, which is r. Okay. Well, let's free up this table. So sine is y over r. What's cos? Adjacent over hypotenuse, so it will be x over r. Tan will be y over x. Okay. For coset will be 1 over, which is r over y. 1 over cos, which is r over x. And 1 over 10 will be x over y, okay? So we get all those ratios, that's okay. Those things will help us to do graph later on, but we're not going to look too deep into that until next lesson, okay? So in here, we got sine here. I'll just copy the cos down as well. Equals to x over r, okay? So if you rearrange it as subject of y, so it will be y r sine theta. X would be r cos theta. See, x and y value can be represented by the radius r and the angle. So that later on in our advanced 2 unit, 3 unit, and 4 unit subjects, that would be extremely helpful. Okay, just give you a head up on that. But in this topic, we only look into the ratios of the x and y components. Okay, cool. Let's quickly do a quick exercise on here. So we basically just want to find a ratio for all these circle and geometry here. And a circle and coordinate here, so my bad. So the first one here is 3 and 4. Let's complete the triangle first. So x component is 3, yeah, y component is 4. So x is horizontal, y is vertical. We got angle here, the radius is 5. So let's draw the triangle bigger. Easy to work on, okay? So you got theta, 3, 4, and 5. Okay, sine x will be opposite over hypotenuse, 4 over 5. Cos will be 3 over 5. Tan will be 4 over 3. That's right. And then that's just basically opposite, 5 over 4. I'm just going to leave it as improper fraction. And 3 over 4. Simple. Second one is slightly more complicated because you got a negative number here. Let's compare a triangle. Because it's always measured from x axis, so it's theta here. So x components negative 4, y components as 3. So let's draw that triangle here. So we got theta, negative 4 and 3, and the radius is 5. So we can still do it easily. So sine is 3 over 5, cos is negative 4 over 5, tan is negative 3 over 4. Yeah, that would be opposite, 5 over 3. 1 over a negative number is still a negative number, so 5 over 4. And coset will be negative 4 over 3. Okay, so pause this video for now and see whether you can do the next two. Just a reminder, it has to measure from x-axis. So the triangles draw like this. Okay, right. Once you're done, here's the answer. Okay. Hope you get them all correct. I apologize, I keep spelling the coset wrong. Here you go. Now, next bit, we are going to look at boundary angles. So, again, we're going to look a little bit deeper into this next lesson. But in this case, we just need to know that what is what, okay? So, for 90 degree, or if you plus and minus, you got negative 270 degrees, or 450 degrees. 90 plus 360, 400, yeah, 450. So it will be this location, and you will get y-axis as r, x-axis is 0, and it's opposite on the 10 degrees. And on 180 degrees, it's just the radius negative, and on 270 degrees, the y value is negative. If you draw the coordinate, those numbers are very easy to find. All you need to know is radius and where it is. Okay. One interesting thing here, 270. If you minus 360, it's negative 90. The other side, I can't bother to work out the other one, but if you have a look, 90, negative 90, 270, negative 270. So basically, it's flipped upside down. So so negative 90 is the same as 270. What I'm trying to say is this. So yeah, just something interesting here. Anyway, so that is what we need to know about boundary angles. Again, we dig a little bit deeper into that next lesson. Okay, here, question 9. I wasn't expect you to draw the lines, but draw all the graphs. But I draw the graph for you for now, because next lesson we're gonna learn how to draw all of them. I draw all the graph here just for us to understand a few things. So, for example, sine theta here. So sine 0 is 0, so it's right here. Sine 0 is 0 is right here. But if we do coset, sine theta can't be 0 because it's 1 over sine. If sine 0 is 1 over 0, we can't do 1 over 0, so there's a reciprocal here. Okay, so we have another reciprocal asymptote here. And same with negative 180 degrees and 180 degrees. Another question it asks is, has cosine has a minimum of 1 when sine has a maximum of 1. So 1 is the biggest it has, but 1 over 1 is 1, which means if they both share the same point, it's an intercept for these two lines. So here, and here. But all other numbers for sine theta is always more than 1. So 1 divided by some number that is between 0 and 1, it always go bigger than 1. So for example, 1 divided by half, it becomes 2. 1 divided by 1/10, it becomes 10. Yeah. So the smaller the number it goes, the biggest biggest reciprocal, or we call 1 over, is bigger. So it goes up like this, and you have a minimum when they meet each other. Okay. That is basically what this question is exploring. I leave the graph for you. You can have a go and try to draw a graph yourself. We're going to look into how to draw the graph next lesson. Okay. Most of the question in this topic is easy. So I'm going to leave you a few questions here, 5, 7, 8, to do as homework. Thanks for watching. Hope you enjoyed this video.